This lesson will focus on how to interpret a function graphically. That basically means how you can obtain some information given a graph of a function. In this example, we're given a function that is called a piecewise defined function, which we'll get into later on in the course, but there are two parts to it. The first thing we need to do is evaluate this function by finding f of negative 3. Remember that f of negative 3 means if x is the value of negative 3, what's the y value that corresponds to that point? The way we find this information from the graph is we go to an x value of negative 3 and go to where the point is on the graph. The point on the graph is negative 3, negative 1, 2, 3, 4. Therefore, f of negative 3 is negative 4. F of 0 means what is a y value when x is 0. We go to the x value of 0, which is at the origin, and figure out where does the graph have a point that corresponds to x equals 0, and that is up above at 0, 2. So f of 0 is that y value, which is 2. Continuing this graph, we want to find all x for which f of x equals negative 1. F of x is another name for y, so we're saying what are the x values whose y value is negative 1? This time we go to the y-axis of negative 1, which is down, and look left or right to find points on the graph. We find a point that has a y value of negative 1 at negative 1, negative 1. So the x value is also negative 1. Find all x for which f of x equals 1. Again, that means what x value have a y value of 1. We go to the y value of 1, which is up above, and go left or right until we find points on the graph. There is a point to the left that is negative 1, 1, but notice that this is not included in the graph because of the open circle. So that's not going to be an x value that we need to include. Another point to the right is at 2, 1. So the x value that we need is 2. Use a graph to determine the x-intercept. The x-intercept is also where f of x equals 0 or where y equals 0. That is ordered pairs of the form some number 0. That would be where is the graph crossing the x-axis, and there's actually no points there, so there are none. To determine the y-intercept, that means to find f of 0, or that is for letting x be 0, we're finding the points 0 some number. Well, the y-intercepts are the places where we cross the y-axis, which there is one here at 0, 2. So the y-intercept is 0, 2. What is the domain of f? We can project our graph down on a copy of the x-axis to find the domain. This leftmost piece continues infinitely to the left, so we'll place an arrow there. The rightmost x value of that particular piece is at negative 1, and it's included there. Then the next piece of the graph picks up at negative 1, though negative 1 isn't included, but it continues to the right of that. And this rightmost piece doesn't stop until this arrow, which is indicating that we continue to the right. So even though negative 1 is where the x values stopped and started again, everything before, after, and including negative 1 is part of the domain. So that really is just everything from negative infinity to infinity. The range we read from bottom up. The bottommost piece corresponds to this arrow that's indicating we continue downward. And the top point of the bottom piece has a y value of -1, and it is included, so we put a circle there. But then there's a gap in our graph, so there will be a gap in our range. It picks back up at this bottom point of the top piece, which is at 1. The question is, do we include it or not? It is excluded on the left part of that, but it is included in this right point where it dips down again, so it is included in our range. And where does the top piece of this end? It ends at infinity. So we have two intervals, -infinity to -1, bracket, union bracket 1 to infinity.